So we will go over these bell work problems together. I'm going to switch to a screen with just problem 1 on it, so we have a little bit more room to work. So number 1 says, write the rule for the inverse of y equals 5 to the x. Y equals 5 to the x. What do we do when we need the inverse? Switch the x and the y. Exactly. That's what we talked about yesterday. We have y equals 5 to the x. And if I start looking for the inverse, I'm going to switch the x and the y. Now, what do we know about the inverse of this form? What form is this? So we're going to look for a logarithmic. I like where you're going. What form is it in right now?
Exponential.
Yeah. Right now it's in exponential form. But Soraya already noticed, we know that the inverse of an exponential form is the logarithmic form. So what should I draw if I want to switch from exponential form to logarithmic form? A triangle, yeah. That is our trusty tool for switching between exponential and logarithmic. So if I have 5 to the y power, 5 to the y power, what do I put in that bottom left corner of the triangle? 5. Yeah, that's my base. Oops. That is my base right there. And I have 5. And along the left side of the triangle, that's my raising. That's my exponent. So what do I put at the top of that triangle? Y. Exactly. We have 5 raised to the y. And then what is our third value? What have we not used yet? X. Exactly. And that goes in our third corner. So now I've filled out my triangle. And we want to go from exponential form to logarithmic form. My log. Where do I look for my log? I start at the bottom left corner and I'm going to go all the way across. My log reads all the way across the bottom. So if I want to rewrite this, I have log. What's the first number I see when I read across the bottom? 5. That's the first number I write. That's my base. And what's the next value I see? X. That's the next value I see, so that's the next one I write. And then the last thing I need to do, I have one more value, but I need an equal sign too. So I have equals y. And we know that we just found the inverse because our second step to find the inverse is to solve for y. And I can see that we have y on one side of the equation all by itself. So the inverse rule of y equals 5 to the x is log base 5 of x equals y. The next part of the question asks us the domain of our first function of y equals f to the x power and the range, the domain and range of y equals f to the x power. What is the domain of an exponential function? It is negative infinity to infinity. So our domain, remember, that's our x's. And if I look at y equals 5 to the x, can put any number that I want in for x. Doesn't matter if it's negative, positive, could be a fraction. I can put anything in there. So I have negative infinity to infinity. That means all real numbers. What does my range mean? My domain is my x values. My range is my y values. Will I ever get positive numbers when I put something in for x? I'll get positive numbers for y. Yeah, I would get positive numbers. Will I get negative numbers? No. Because even if I put a negative in for x, when I have a negative exponent, it becomes a fraction. So it'd still be positive. So if I know that I'll get positive numbers but never negative numbers, what is my range? 0 to infinity. It means I have all the numbers above 0, all the positive numbers, but no numbers below 0, no negative numbers. Okay. So we said earlier that finding the inverse means we're switching our x and our y. And we just said that domain is x and range is y. So if I want to do the domain of the inverse and the range of the inverse, what would I do to my domain and range from that function? Yeah, exactly. I switch them. So the domain of the inverse will be 0 to infinity. And the range of the inverse will be negative infinity to infinity. I just switched those two. Okay, I am going to switch to the next screen to do number 2. Make sure everyone's with me. Okay. So we have 2 logarithmic expressions and we want to condense them. Part A says natural log of 2 plus 4 times natural log of x minus 6 times natural log of y. What is my order of condensing? What's the first thing I look for?
Power.
The power rule? Yeah, exactly. So what do I look for in that expression to tell me that I have a power?
Numbers in front of the log.
The numbers in front of the log. So in this one, I see I have a 4 in front of that natural log, and I have a 6 in front of that natural log, and those will become exponents. So I can rewrite this, and I'll bring natural log of 2 down because I'm not changing anything there yet. And I'll write natural log of x, but that 4 becomes an exponent there. And then I'll bring my negative, my subtraction sign down, because I'm not doing anything with that one yet. And I have natural log of y, but that 6 moves from the front of the log to the exponent, and I have a natural log of y to the 6th. Okay, what is my second step in the order of condensing? What do I look for next? The product rule. So what am I looking for to tell me if I have a product? The addition sign? Exactly. So when I have addition between logs, I'm going to multiply their arguments together. So I have natural log of 2 times x to the 4th. I multiplied their arguments together. That's the product. But I haven't done anything to natural log of y to the 6th, so I'll just bring that down. All right, I've done my power rule. I've done my product rule. What is my third step in condensing? My quotient rule. Exactly. That is the one I haven't looked at yet. What would tell me, what symbol tells me if I need to use my quotient rule? Subtraction. And I see a subtraction sign. So, subtraction tells me I will have a quotient. I know that a quotient is something divided by itself. So I know I'm going to want to divide those arguments. Have natural log of 2x to the 4th divided by y to the 6th. Okay. Is that what?
So we need 2 times x to the 4th and 2x to the 4th.
Oh. Yeah, is there a difference between 2 times x to the 4th and 2x to the 4th? No, I can write it either way. That is exactly what that means. Great question. Okay, am I done condensing? Yeah, Belzy.
Can you also write it like n base of 2 x like this? Or does it have to be like that?
That is the change of base formula, so it would all be together like that.
Okay.
Good question. All right, are we done condensing? Yes? Great. How do we know?
There's only one.
Say it a little louder.
There's only one log.
Because there's only one log, and what else? There's no more addition, subtraction, or anything in front. And there's only one argument. There's only one big parentheses there. All right. So we can do the same process for part B. It asks us to condense. So we know our first step in condensing. We said that's power rule. Do we have power rule in part B?
Yeah, both of them.
Yeah, which numbers?
2 and 3.
I have my 3 and 2. Both of those will become exponents. Can I simplify that at all? Yeah, what could I do to simplify that?
Actually,
Yeah, even before I go to my product rule, I know what 3 squared is. I could just rewrite that to make it a little bit easier for myself. And just have log squared, log base 2 of 9. And then now, I can go to my product step. What symbol do I look for in my product step? Addition. Do I see addition in that last line? No, I don't. So there's no product rule. There's no addition. But I still have to check for quotient rule. That's my last step. What symbol do I look for quotient rule? Subtraction. And I see I do have subtraction. So I want to divide my arguments there. All right, am I fully condensed?
Yeah.
Yeah. How do I know? How do I check?
It's one log, one argument.
Because there's one log and one argument. Exactly. That is fully condensed. Okay, we have one more problem in the bell work. And I'm going to move to the next page. This will be up on Canvas later today, but if you want to take a picture now, that works too. And I'm going to move to the next screen. Okay, it says, Talia and Miles bought toys from the same store. Talia spent $131 on 7 Hot Wheels and 8 Barbies. Ryan spent $94 on 14 Hot Wheels and 2 Barbies. And we want to find the cost of 1 Hot Wheels car and 1 Barbie. So when I look at this first, do I notice any totals? Do I have any totals? Yeah, what totals do I have? 131 and 94. So I know that I'm going to set one equation equal to 131. And I will have 1 equal to 94. What are my 2 variables? What are the 2 things I'm looking at? Hot Wheels and Barbies. So I want to define my variables. What would my variables be? X and Y. That can work. What would X and Y represent? Can I do Hot Wheels as X and Barbies as Y? Okay, so I saw my totals. I defined my variables. What would I do next? How many Hot Wheels and Barbies do I have?
Left to right.
Yeah. Or what do we notice? What is it telling us?
So 7, 8, and 14.
Yeah, so Talia has 7 Hot Wheels and 8 Barbies. How would I write that? 7 Hot Wheels and 8 Barbies.
7x, 8y.
So I have 7 Hot Wheels and 8 Barbies. 7x plus 8y equals 131. And I also, just like that, see 14 Hot Wheels and 2 Barbies. 14x, 14 Hot Wheels and 2 Barbies. What methods do I know for solving a system of equations? I have 2 equations right here. Bless you.
Is your
Elimination method? Yeah, I can use the elimination method. What would I need to do to use the elimination method here? By what number?
Multiply the first equation by -2.
Absolutely. Buzzy, why do you want to multiply the first equation by -2?
Because if you multiply the first equation by -2, it's going to cancel the x's out.
Yeah, exactly. So we want to cancel out one of our variables. We want to eliminate one of our variables. And so if we multiply the first equation by -2, we'll end up being able to cancel out our x's. And now we can add those two together. We have 14x minus 14x, and just like we said, that cancels out. 2y minus 16y. 2 minus 16 would be negative 14y. And 94 minus 262, where we pull out our calculator. Negative 168, thank you. And our last step to solve for y would be to divide by negative 14. Negative 168 divided by negative 14. What's that? Would be y equals 12. Okay, I solved for one of my variables. Am I done yet? No, what else do I need to do? Plug that into one of the equations. Do you have a preference for which one? The top one? Okay. So we have 7x plus 8 times y, which is now going to be 12. It's 131. All right. We have our calculators out. What is 8 times 12? 96. 7x plus 96 equals 131. We want to move the 96 over. What is 131 minus 96? 35. And our last step, divide each side by 7. X equals 5. So we know that the cost of one Hot Wheel X is $5, and the cost of one Barbie Y is $12. Is there some word on here? Is there a word? Yeah. Sorry. Okay, we'll switch over to looking at our practice test. And it looks like our first one that we'll look at is problem 11. Problem 11. Okay. That is not going to work.
Oh, that's right. We here. You remember how to
Yeah.
throw it up? I totally forgot about that. Okay, grab it. Should be able to grab it now.
Yes. Okay. Problem 11 says, what is the base of the function y equals 5 to the x? What is the base of the function y equals 5 to the x? Yeah, it's 5. So we know that when we have it in exponential form, at 5, our base is 5. Part B, we just practiced this in bell work. We said write the rule for the inverse of y equals 5 to the x. What form is it in right now? Exponential form. So what is the inverse? How do we get the inverse? It's going to be logarithmic, yeah. What do we do first? We switch our x and y. So we had y equals 5 to the x. And we switch those, we get x equals 5 to the y. And just like we said, we know it's an exponential form, and we want it to be in logarithmic form. And that is what I know. I'm going to use my triangle because I have exponential and I want logarithmic. So we said our base is 5. Yeah, the 5 is going to be on the left. And the top would be y. The bottom would be x. Exactly. We had our base 5. We raised it to the y power. That goes up the left side of my triangle. And the other one is x. So if I want to write this in logarithmic form, where do I look on my triangle for log? On the bottom. I start here and I go across.
That's just the first problem.
Yeah, we're on the practice test though now. So, how would I rewrite it using my log? Yeah, so I looked all the way across. I said, I start with log. The first number I see, 5. That's my base. Next one I see is x. The last value that goes on the other side of the equal sign is y. But now we want to graph the original function and its inverse. So I am going to move down to our tables. I have x and y. And I know that I'll use my 5 x's that we always use. And over here, we're using our y equals 5 to the x. So for my first one, y equals 5 to the negative 2. My negative exponent flips to the bottom. And my first y value is 1 over 25. 1/25 over 1/25, yeah. So my first point is negative 2, and then right above this x-axis. And I keep going. I keep plugging my x values into that original one. My second point is negative 1/1/5, so right above the first one. When my x is 0, I know that anything to the 0 power is 1. So I have 0, 1. When x is 1, that's 5 to the first power is 5. 1 to the 5th. And when x is 2, 5 to the second power is 25. So 2 to 25 will be way up past our graph. But I can still graph it knowing that. So now I'm wanting to graph the inverse. And I know that I could plug in all my x and y values, but what else could I do if I'm going from one table to the inverse? I can flip the x and y. So here I have negative 2 1/25. But if I flip those x and y values, if I switch them, I have 1/25 negative 2. 1/25 negative 2. And I can keep flipping each coordinate pair. I have 1/5 negative 1, 1 0, 5 1, and 25 2, which is not on my graph, but it still can be graphed. So that's part C, says graph the original function and its inverse. Now we want to state the domain and range of the original function. So the domain, my x values. What x values could I put into my blue function? I can put anything I want in for x. But my range, my y values, I can tell they're never going to go down here for my blue graph. They'll never go below 0. And I know that my range is 0 to infinity. What's our trick that we know for domain and range? We just switch them. Our x's and y's were switched, so our domain and range are flipped. Yes. Thank you. Okay. Now we are going to look at number 8. Number 8 is next. So number 8 says, Maya, Eduardo, and Darius were all given different logarithmic expressions to simplify by condensing. Maya was given log base 5 of 3 plus 2 times log base 5 of 2. Eduardo has log base 5 of 96 minus 3 times log base 5 of 2. And Darius has log base 5 of 2 plus log base 5 of 6. And each of them condensed and simplified their expressions correctly. Right off the bat, they tell us that. But they're confused because they all arrived at the exact same answer, log base 5 of 12. How is this possible? Well, my first thought is that I can check that. If I see this and I know we're condensing, I know Maya's first step was to do the power rule. And log base 5 of 3 plus log base 5 of 2 squared would be, sorry, was that too much? Would be the same as log base 5 of 3 times 2 squared, and that's 3 times 4. So if I know that they're all using condensing rules. If I took each one of these and condensed it using my order of condensing, each person can have an equivalent expression. So, by following the order of condensing, each person had something equivalent to log base 5 of 12. Can I keep going? Cool. Base 5 of 12. So, we know that it's possible because even though each student had a different expression to start with, as long as you follow the order of condensing, it's perfectly okay to have the same expression at the end. Last one. Yeah. All right. Sorry. So we are going to now look at number 3. Number 3, this one can be quick. How would we find the inverse if we were given a table? That's something we just looked at. We just switch our x and y values. If we had a graph, we reflect the original graph over the line of x equals y equals x, excuse me. And our function rule, what we've been practicing the past couple days, if we are given a function rule, we switch our x and y values, then solve for y. Okay. Our test is tomorrow. Remember, you can use one sheet of notes, front and back, handwritten. That does not mean your practice test, just one page of notes.
That being said, if there's stuff off the practice test that you want to copy onto your note sheet, you may do so. Yes.
We will have a key for this practice test up probably in the middle of the day, as soon as possible.